All right, the great white shark, here we go. Great white sharks have triangular teeth. Did you know that? That's interesting because now we know a lot about triangles. The height of one of these teeth is 6 centimeters. The area is 15 square centimeters. What is the measure of the base of this tooth? I'm going to tell you that I really don't care because I just don't want to see one. But that's beside the point. We're going to solve this problem. But before we do, there's a couple of things you have to know. So let's take a look at your workbook where it says, or your slide that says, keep this in mind. Okay? In the last lesson, we needed to write out and solve equations. Sometimes we don't have to do that. Sometimes we can just plug in all the information we have into a formula as long as there's only one unknown in that formula, and we can solve it that way. And we can just do a little arithmetic. And notice there's a difference between when it says solve algebraically. When it says solve algebraically, we got to be a little bit more creative about writing equations. When it doesn't, we get to use a little bit more of what I call plug and chug, and you've heard that before, okay, where you just plug in what you know. So let's go back to that great white shark, and let's take a look. It says that it's talking about the base, the height, and the area. So here's what we know. We know for the area of a triangle, remember it's the great white shark, we know the area equals 1/2 base times height. We've learned that, and we've dealt with that for a long time. So here's what I know. Okay, they have triangular teeth, which is why we did this. The height of one of these teeth is 6. So we know the height is 6 centimeters, and the area is 15 square centimeters. And we want the base. So notice there are 3 unknowns in this formula, or 3 variables in this formula, and we have 2. As long as we have all of them except for 1, we can just plug and chug. So I'm going to do this. So this is 15 equals, because that's the area, 1/2 the base, which is, I don't know, didn't really need parentheses there, times the height, which is 6. Now, remember these are 3 factors, 3 things attached by multiplication. The rule is I can multiply any 2 factors first. Well, I'm going to multiply 1/2 of 6. That's quite easy. 1/2 of 6 is 3, so this is 3b. Oh, look at that. That's a thing of beauty. Didn't need a key, didn't need to write an equation, didn't need to do anything. Now I'm solving this. And we know the base of this tooth is 5, and I think they're calling it centimeters. Yes, 5 centimeters. So that's the base of the shark's tooth. Either way, I don't want to be in the water with a shark. So that's how you do that problem. Really kind of simple. We just use a formula. So this section is a little bit more about just formulas. So that's the area, the base of the shark's tooth. Now let's take a look at some of these other questions. All right, here we go. Now we're going to solve these for the unknown variable. Well, let's talk about what the unknown variable is. We have v, we have r. Well, it looks like we don't have pi, but pi is a constant. Remember, it's that 3.14 and actually goes on forever. So when we get our answer here, it's not going to be exact, because the only way to be exact is to keep it in terms of pi, but the directions say use 3.14 for pi. So the only thing we really don't have is the h. So that's what we're solving for. But again, all we're going to do is plug and chug. So here we go. So v is 47.1 equals 1/3 times pi, 3.14 times the radius squared times h. We don't know h, remember. So that's how we start. And now this looks like a mess. So let's look at 47.1 equals order of operation, exponents first, 1/3 times 3.14 times 9h. Now I have to tell you, this is not that hard because these are 4 factors, but just to show you later, what you might want to do is you might want to think of these like this. It might be easier later if this wasn't so simple. The reason I'm calling this simple is because I can take 1/3 of 9 easily, but that doesn't always work that way. So you might want to do something like this. This is 1/3 times 3.14 over 1 times 9 over 1 times h over 1. Now, again, I can reduce quite easily. If I can reduce, you might want to reduce. If not, you can just multiply the whole top and put it over 3. But again, I can reduce easily, so I am going to. 3 goes into 3 once, 3 goes into 9 3 times. So now I have 47.1 equals 3 times 3.14, which is 12 carried a 1, 4, 9.42h. That's what I have. Remember, I'm solving for h. So again, this is just pure plug and chug. So I'm dividing by 9.42. I'm dividing by 9.42. Okay, I'm going to have to show you that division. To do that, I'm going to erase the top part of this and do division up here because I don't want to erase this. Okay, so ready? Okay, so this is what I have. I have to move this over twice, 1, 2. So I have to move this over twice. I'm going to have to add a 0. So what I really have is 942 into 4,710. Now I'm going to divide. How much fun is this? Okay, so 942, I'm going to have to put into the whole number because it doesn't even go into 471. So 942, I'm going to multiply by 5 just because that sounds clever. Okay, 10, 21, 40, oh, look at that. You know why I guessed for that? Because I went 900 to 4,700 is about 5 times because 9 times 5 is 45. So that was kind of clever. So 5. And remember that was h. h equals 5. That was the height, and the height, oh, it was no units. So h just equals 5. So all I did was plug and chug. Very simple. All right? Let's take a look at this one. Do you remember this? This is the formula for an area of a trapezoid, if you remember. I'm going to plug and chug and see what we got. We know the area is 45.5 equals 1/2 the height, which is 7. Big B plus little b. Oops, sorry, big B we have. Big B is 8. Sorry about that. Now, this is absolutely up to you. You have a couple of things you can do. These are 3 factors. I can multiply this whole side by 2 to clear the fraction, or I can take a half of 7. Okay, I can go half of 7. Half of 7 is 3.5, and I could do that. Okay, do it the long way, just divide, division. Okay, and this is 8 plus b. I can do that if I want, or I could put this 1 times 7 times this all over 2, however you want to do it. Now, 45.5 equals, I can distribute 3.5 times 8. 3.5 times 8, 3 times 8 is 24. Half of 8 is 4. That's going to be 28. I don't expect that you could do that in your head. Maybe you can, but if you can, it's okay. So this is that. Now we're going to subtract 28. Don't remember the point 0. This is 5. 5 minus 8 cannot do. This is 7. This is 17.5 equals 3.5b. Want to take a guess? I'm thinking this is going to be 5. Let's see. 3.5 times 5. 25, 2, yep, 5. Oh, look, 5 is always our answer, it looks like. But that's little b, which is 5. And that's how you do that problem. So there's 1 and 2, and how you do the arithmetic is absolutely up to you, whatever you feel comfortable with. If you'd rather clear that 2 and get rid of the fraction, that's fine. If you like doing it this way, that's fine too. Whatever makes you happy doesn't matter. We have one more to do from this slide, so we're going to erase the board and do that problem. All right, does this look familiar? To some of you it probably does. This is the slope formula. For those, we have not done this yet in any mod, and we will do it. Just, I think it's mod 12, I'm not really sure, or mod 97. No, we don't go that far. Anyway, this is the slope formula, and we're going to just plug and chug. Look, we have 1, 2, 3, 4 numbers, and we have 1, 2, 3, 4, 5 letters. So that means there's one unknown, so we can just plug and chug. Let's see what happens. M is 1/3. Y2 is my unknown. Y2 minus Y1. Y1 is 3. X2 is 7. Minus x1, which is a -2, a double sign. I'm going to use a parentheses if you recall that. I'm sure you do. And this is 1/3 equals y2 minus 3 over 7 plus 2. Remember, minus and minus changed. We have to make it one sign, and since they're the same, it changes to a plus. So here's what I have so far. 1/3 equals. If you want to take the 2 out of there, that's fine. If it's easier for you to understand, it doesn't matter. Remember, that just means, oh, let me tell you what that means. I'm sorry. These are subscripts. They're not exponents. They're subscripts. Did I say that as one word? They are subscripts. And what that means is that I need two points, okay, and that this is the y of one of the points, this is the y of the other point. It's like I have two nephew Frankies. One we call Frankie 1, the other we call Frankie 2 because they have the same name. That's a long story. At any rate, I now have an option here. I can do one of two things. I can either cross multiply if you remember proportions, and you should because it's been in the homework, or we can do this as a fractional equation, which is fine too. If we do this as a fractional equation, which is what we've been doing, so I might as well just continue doing that. We can multiply both sides by 9. We get 3 here. Good night here. Good night, Irene. So up here we have 3 times 1. Oh, I got it. Don't worry. Okay, 3. You were hoping I lost that marker, so I had to stop, weren't you? 3 times 1 is 3 equals 1 times y minus 3, which is just y minus 3. Add 3, and we get y equals 6. If you want to be, you know, that really was y2, but it's okay. That y2 equaled 6. Okay, because remember, that's the unknown we didn't have. Okay, so y2 equals 6. I just thought it might be easier to take the 2 out of there just because I was afraid you'd think it was a square. And I didn't want you to confuse that. So that's the slope formula, but it doesn't matter what form of it is. My point is, if you have only one unknown and you have all the other numbers, you can just plug and chug and do some arithmetic. Pretty cool? All right, so in the next slide, there are 3 problems. You try those, and then click back when you're ready. All right, here we go. You try these. These are almost like the problems we just did, just seeing if you can do them. It's a little different. This is 4/3 pi r cubed. Why did I do that? I had to plug in 5 for r. Remember, this is the volume of a sphere, if you care. But of course, you know that because you've been doing those problems. Okay, here we go. We're going to do order of operations. Oh, pi is 3.14. I'll put it in now. Should have did that earlier. Sorry. 3.14 times 125. 5 cubed. 5 times 5 is 25. Times 5 is 125. So that's where that number came from. Now I'm going to do this. Ready? 4 times 3.14 times 125. Because these are all going over 1. Does that make sense? I hope that makes sense. 3 times 1 is 3. Times 1 is 3. Now, 4, 5, 8. That's not divisible by 3. 5, 6, 7, 8. That's not divisible by 3. We're actually going to have to do this problem out by multiplication. Okay. Ready? I'm going to multiply 125 times 4 because that's pretty easy. Doesn't matter. But 125 times 4 is 500. Oh, that's going to make my life so easy because, right, see what I did? 125 times 4 is 500. That was beautiful. Let me show you why I'm so excited about that. I'm so excited about that because now I'm going to do this. 3.14 times 500. I actually am going to do this. 5 times 4 is 20. I'm not worrying about those zeros. 5 times 4 is 20. Carry the 2. 5 times 1 is 5, plus 2 is 7. 5 times 3 is 15. Now there's 2 places there. Now I have to add the 0, 0. Sorry for the 500. And no places there. So here we go. 1570. Okay. So this is 1570 divided by 3. Now, is this good? 7 plus, no, it's not good again. Okay, because 7 plus 5 is 12, plus 1 is 13. It's not divisible by 3. Okay, here we go. We're going to now divide. You ready for the division? Here we go. Were you saying some bad words against me when you were doing this? 3 into 15 goes 5. 3 into 7 goes twice with a remainder of 1. 3 into 10 goes 3 times with a remainder of 1. So we're going to keep having this remainder of 1. So I'm just going to do 523 and 1/3 because that's a little bit more exact than a decimal point. 33333 since they didn't tell me where to round. It just said solve the unknown, use 3.414. So we're going to leave it like this. Volume equals 1. Sorry. No. It is volume. Okay. Oh, it is volume. Volume equals 523 and 1/3. Did they give us any units? No units. So we're done there. So that's what we got for that problem. I was hopeful that was going to be divisible by 3. But it's okay to get fractions. It just takes a little bit more time. Okay, ready? I think this one's going to be easy. Ready for easy? I'm ready for easy. 117 equals 1/2 the height. Do we have the height? We don't have the height. So h, big B, is 15 plus little b. Oh, I'm loving this problem. Do you see why I'm loving this problem? If you're not sure, you'll see why in a minute. 117 equals 1/2 h. I'm going to put the h over 1 if that makes you happy. Does that make you happy? I can tell you're really happy. over 26 over 1. But now 2 goes into 2 once, 2 goes into 26 13 times. This is 117 equals 13H. Could I have been that mean to give you a hard decimal again? I don't think I was, but I don't remember to be quite sure. It was a long time since I wrote this problem. I'm going to think through. Ooh, I think this doesn't go nicely. Oh, it might. 9? 9, I'm thinking. You know why I picked 9? Because 9 times 3 ends with a 7. 27. 117. Beauty! So H is 9. Again, do you see why I picked 9? Because 9 times 3 is 27. Would end with a 7. This ended with a 7 because I had to divide here by 13. Okay. So H is 9. That was beautiful. Not as ugly as that one over there. Okay, so we have one more. Didn't fit in the space. We'll have to do that one in a minute. I must have felt bad about that first problem because this is easy. Look what's missing. M is missing. So this is going to be easy. This is just a matter of, like not even dividing because we can leave our answer as a fraction. Y2 is 7. So this is 7 minus, don't really need parentheses there. It's not a double sign, but what the heck. I want a parentheses there. X2 is 3 minus X1, which is 5. Awesome. That's all we have to do here. This is so easy. M equals 7 plus 3 over, I have 3, I owe you 5, that's negative 2. This is 10. Oh, it even divides nicely. We could leave it as a fraction, but we can't here because it divides so nicely. Negative 5 is our answer. The slope of this line, whatever line this is, it's a line that is comprised of some points, is negative 5. Wait till you see what that means when we get to mod 12. That is so cool. That's a steep, steep line. If you're a skier, you're going to love that line. Okay, anyway. That's the end of number 3 and the end of this slide. Let's see what else we have. All right, let's look at this one. The length of a rectangular garden is 20 feet. Okay. Now, I'm going to tell you, before we did a key, and I said you can write a triangle or you can write the key. For rectangles or anything with 4 sides, I like to draw it, and I'll tell you why I like to draw it. And I like to call, I like to say width, length, and it doesn't matter which side you call the width and which side you call length, and I'm going to show you why. Because if I just write the key, the only dimensions of a rectangle are the width and the length. If I just write a key like that, and I'm not saying we need a key, I just want a diagram right here, but if I did this, well, you're really missing 2 sides. I don't want you to lose sight of the fact that there's 4 sides just because you only have 2 in the key. So I don't like to make a key when there's 4 sides, but, that's my own thing. All right, so here's what we got. The length of a rectangular garden is 20 feet. So we know this is 20. Okay, we know the area is 300. So we know the area is 300 square feet. And we want to know the width of the garden. Well, here's what else we know. We know area equals length times width. So take for a second what we know, what we understand about this problem, and try to solve this. And click back when you're ready. All right, let's see where you got. We know the area is 300, so we can plug that in. We know the length is 20, and the width is what's unknown. We could leave it a W if that makes you happy. Now we'll divide by 20. We'll divide by 20, and W equals 15, and it's feet. Okay? Because the area is in square feet because the length and the width were feet. So it's 15 feet, and we're done with that problem. Really easy, plug and chug. So even the words didn't bother us because we still have a formula with only one unknown. We just plug and chug it out and do a little arithmetic. Okay, so now let's look at some other problems. All right, now listen, you have to really think about this. Here's the question. Which has more pi? One 15-inch pie, so you have a 15-inch pie. And of course, that's a beautiful circle. I know, stop laughing. Or 2 9-inch pies. Now I have to be honest. There's something that it says that you got to listen to. This 9-inch, 15-inch, I think it said, right? That's the diameter of the pie. Okay, so the diameter, remember, was the distance across the center. So this is 15 inches, and that's 9 across. And you know how good I am at doing everything exact, That's oh my God, the last one's the worst. Okay, at any rate, that's what you have. Now, let's understand what we're trying to do here. Do we want the perimeter of the pie? If we eat the perimeter of the pie, think about what exactly that means. That means you have a pie and you're eating, around the pie. It's kind of like eating the crust of the pie, all around the pie. That's not what you want. You want the area. So really what you're asking is, what has more pie, either the area of this or the area of these two put together? Now, I have to tell you, first we need the area of a circle. So the area of a circle is A equals pi r squared. To be honest, we could deal with pi, but we don't have to. Here's why. Okay, let me show you. I'm going to do this without dealing with pi at all. I mean, we have to have pi in the formula. We're just not going to change it to 3.14, which makes it, if you recall, more exact. If the diameter is 15 inches, then we have to figure out what the radius is. Well, I know you know how to do this. We've talked about this before. Well, the radius is half of the diameter, so the radius is half of 15, or 7.5. So what we have is 7.5 squared. Okay, to do this, we have to take 7.5 and we have to square it. So and I remember I showed you the trick for this, but 7.5 times 7.5 is 56.25 pi, and it's square inches. So that's the area of that pi. The area of this pi is, let's do this thing. Remember the radius, this is the diameter, so the radius is 1/2 of the diameter, which is 4.5. So the area, inches, so the area is pi r squared, which is pi times the radius, which is 4.5 squared, which is 4.5 times 4.5, which is 20.25 pi. But that's 1 pi. So now we have to take this 1 pi and add it to the second pi. This is the first pi, the second pi. And we get 40.5 pi square inches. Well, which has more pi? Well, 40.5 is not as big as 56.25. So this has more pi. And when I say pi, I mean P-I-E, not pi, as in the Greek letter pi, okay? So the 15-inch pi, 15-inch diameter, has more. Okay, so that's the end of that question. All right, this is a good problem. You just have to really understand what's going on here. It's 328 miles from New York to Baltimore, okay? We want to know how long it takes Shireen to drive round trip. So round trip means she's going from New York to Baltimore, and then she's coming back home. So understand that means she's driving 328 times 2, because she's coming back. Now let's assume, it doesn't say, okay, but we have to assume she's going at the same route, okay? So 16, that's 5, that's 656 miles. That's how much she's driving. And we know that she's driving 64 miles per hour. She's driving 64 miles per hour. That is her rate of speed. We want to know how long it takes. I think, but I can't be sure, but I believe in our last and some of our other mods, we talked about this formula. Distance equals rate times time. Where if I'm driving at 60 miles per hour for 2 hours, I go 60 times 2, I would have gone 120 miles. Okay, and we call this D for short, D equals RT. Okay, well, here's what I know. I have the distance, because this is the distance, 656. I have the rate of speed, miles per hour, per second, per minute, per whatever is the rate. And that's 64, and the time is what I don't have. So we're trying to find time. We divide by 64. We divide by 64. Is this going to come out nice? I don't know. Not real nice. I think we're going to need a decimal here. So here we go. T equals, we're going to have to divide here. All right, here we go. Let's divide. 656 divided by 64. You can reduce if you want, if that makes it any easier. But either way, you know what? Maybe want to reduce? Let's leave it. It doesn't matter. Okay. Here's the decimal. Let's bring it up before we forget. 64 goes into 65 once. Let's bring down. That's 6. That goes in 0 times into 16. We have to add a 0. Goes into goes into it twice. 64 times 2 is 128. Subtract. 32, bring down to 0, 320. 64 into 320. 64 times, I'm thinking 5? Yes, 5. So 10.25. So it's 10.25 hours. Now, I have to tell you, I really want to talk about what this means. 10 and a quarter or 10.25 hours, and we probably could have got that 0.25 easier if we talked about the remainder and reduced the remainder, either way. But I want to talk about that 0.25 hours. We can change that to minutes, okay? Let's talk about changing that to minutes. 0.25 is 1/4 of an hour. 1/4 of an hour is 15 minutes. But let's say you didn't know that. I can take 0.25 and multiply it by 60 minutes, okay? And that should give me 15, so let's do that. 6 times 5 is 30, carry the 3, 12, 15, add a 0, 2 places. There's your 15. So it's 15 minutes. So this is 10 hours, 15 minutes if you care about minutes. 10 hours, 15 minutes, or 10.25 hours, same thing. Okay, so that's the end of that problem. Didn't come out totally nice, but it didn't come out bad. 10 hours, 15 minutes, or 10.25 hours. Okay, let's take a look at this next problem. All right, now we're going to talk about temperature. F equals, which is Fahrenheit, equals 9/5 times C, which is Celsius, plus 32. This formula will take Celsius and change it to Fahrenheit. So we're going to do that. We want to change 48 degrees Fahrenheit, Celsius, to Fahrenheit. So let's see how we can do this. Notice we can't reduce here. We're going to have to multiply through. All right, ready? 48 times 9. 9 times 8 is 72. Carry the 7. 9 times 4 is 36. 432. 432 over 5 plus 32. Okay, we could get a common denominator, but basically I don't want to, because in the end I don't want to tell you how much Fahrenheit is in a fraction. So I'm going to divide here. Okay, so you ready? I'm just going to take this off the board for a second so it's not confusing. And I'm going to go 5 into 432. Here's the decimal. 5 into 43 goes 8 times, remainder of 3. 5 into 32 goes 6 times. That's 30. It's got a remainder of 2. 5 into 20 goes exactly 4 times. So that's 86.4 plus 32. Remember how to do that. 86.4 plus 32. Line up your decimals, which is 118.4 degrees. That's hotter than a day in Florida. So 118.4 degrees is what 48 degrees Celsius is. That's the degree measure in Fahrenheit. That's the degree measure in Celsius. Okay, we're going to try another problem. All right, I think this is a really cool problem because it's, that Fahrenheit to Celsius, that's nice, but I can hit my button on my computer to do that. I think this is a cool problem because it says a building contractor is to dig a foundation, okay, 12 feet long, 9 feet wide, and 6 feet deep. For a toll booth, the contractor pays $10 per load for trucks to remove the dirt. Each truck holds 162 cubic feet, and each load is $10 to haul it away. Now, here's what's going on, right? I'm building this foundation, so I'm digging out this dirt. And as I dig out this dirt that fits in this hole I'm going to make, okay, I'm paying for the dirt to be removed. So that's what's going on. So the first thing we have to figure out is how much dirt are we actually digging out. Okay, to do that, that's volume, right? That's the volume of this 12 feet long, 9 feet wide, 6 feet deep rectangular solid. So the first thing I have to do is find the volume of what they're calling the foundation, right? So volume equals length times width times height. And you know that because that's been in the homework for a while. So here we go. This is 12 times 9 times 6. Okay. I just multiply any two first. 12 times 9 is 108 times 6. is 648 cubic, because remember, volume is in cubic feet. Now, we have to get all this dirt hauled away. For each time they haul a load away, it's $10. However, every time they haul a load away, they can only hold 162 cubic feet. Okay? So I have to figure out how many 162s are in this number. So I have to divide. So that's the second thing I have to do. How many loads? So the number of loads, I did say loads, is 648 divided by 162. Now, I'm hoping, I think that looks like it might be 5. So I'm going to check that out. No, it can't be 5. It doesn't end with, let's try 4. That ends with an 8, right? No, it's not going to be that either. 4 times 2 is 8. 4 times 6 is 24. Oh, that's way too, no, 648. Oh, it is. Hello. 648. So it is 4. So we have 4 loads that we want to haul away. That's nice. That's how many loads. That's not the question. The question says, what is the cost? Well, every load is $10. So the cost is 4 times 10, which is $40. So it takes, this is very cheap, but it takes $40 to haul all that dirt away. You have to haul dirt away? Why don't you just put it somewhere else? But anyway, $40 to haul it all away. And that's the end of that problem. 3 steps, kind of a cool problem, a problem that might occur in everyday life. All right, volume of a cylinder. It says, what happens to the volume of a cylinder when their radius is tripled? Remember, this is like a cylinder. That's all it is. It's just a can. All right, now, here's the deal. The deal is we can plug numbers in, but what happens if it only happens for that particular number? We have to prove that this happens for any number we put in for the radius. So this is how we're going to do this. This is the volume of a cylinder. That's the formula for the volume of a cylinder. Pi r squared times the height. And if you remember why, here's why. The reason is because the volume of anything is the area of the base, which is a circle, pi r squared, times the height of the figure. So that's why it is pi r squared h. So that's the volume of any cylinder. Now, we're going to triple the radius. So instead of putting r in here, we're going to put 3r, because this is like 1r squared. We're going to put 3r. That means I'm tripling the radius. V equals pi times 3r squared h. That's what I'm going to do there. So volume equals pi. Now I'm going to take this expression and square it. That means I'm going to take 3r and multiply it by 3r. If you remember what we did a couple of mods ago, to multiply 3r times 3r, if you want to make it a big r, that's fine. Actually, usually you do use the little r, so I'm going to go back to a little r here. I don't know why I felt like getting fancy there. 3r times 3r. We multiply the coefficient. 3 times 3 is 9. Keep the base r and add the exponents, because r times r is r squared. So this is 9r squared times h. So if we want to write it, the coefficient, which is the 9, is usually in the front, 9 pi r squared h. So all we're doing is now comparing this to this. Well, it's almost the same, except we've multiplied the pi r squared h by 9. So what happens to the volume? The volume is multiplied by 9. It's pretty cool. Now, what does that mean for me and you? You know I'm going to ask that, right? Watch. Let me just give you an example. Here's the example. Let's say you have the volume. You want the volume of a cylinder when the radius is 2. Okay, remember the answer to this question. Volume is multiplied by 9. I'm going to take this off for a second. Let's say the radius is 2. This is in my head. This is in my head. This is extra info. In my head. This is not a proof. In my head. Okay, here we go. The radius is 2. Its volume equals pi times 2 squared times h. This is 4 pi h. That's the volume of that figure. I'm sorry, we're going to need a height of the figure. I apologize. Oh, you know what? Let's leave it. Yeah, let's leave it. Because that would be for any height, right? 4 pi times the height, any height. Okay, I don't even need a height. Now let's triple it. Triple the radius. I kind of like that, because I don't want you to think it happens for that particular height. So let's triple that radius. So let's make the radius 6, right? Triple it means to multiply it by 3. Now watch it. Volume equals pi r squared h. pi r is 6 squared times the height. This is 36 pi h. Well, the pi and h are the same here. What is the pattern with the 4 and the 36? Well, 4 times 9 is 36 because the volume will be multiplied by 9. That will happen no matter what my radius is, as long as my height stays constant. So the height of this will be the same as the height of this. It will always multiply by 9, keeping the height constant. Pi r squared h, we're done. That is not the answer. The answer is the volume is multiplied by 9. That's just showing you what's going on. And that's the end. And that's a whole lesson on formulas and problem solving, where all you need to know is all of the unknowns but one, and we can just plug and chug. And that's it for lesson 7.